Okay, so we've got the calculus tutorial sheet that we just want to answer. So it's focusing on continuity, definition of limits, or specifically the definition of derivatives. So if we check first one, this piecewise function, then we're trying to focus on the aspect of continuity. As you can see, most of the questions are asking about that. And then using the definition of the derivative, that is the first principles, we need to calculate the derivatives of the following functions, and then in the following find the indicated derivatives, differentiate. So all these questions are basically answered in this video. So we'll start with the first question. Okay, so this is a piecewise function. Now if you look at the questions that we were given, the first one says, is the function continuous at x is equal to -1? Is it continuous at x is equal to 1? What values of x is the function continuous? What value should be assigned to a function to make the extended function continuous at x is equal to 2? So at the end of this question, you understand what it means for a function to be continuous. So to just help you understand and analyze whatever we are talking about, I'll sketch the function that we've been given. Alright, so let's come up with the xy plane just there. Now let's try to analyze the domain that we have and break it down. So we have from -1 to 0. So let's come up with -1. You can put -1 there, and then we can have a 0 there, and then we are going all the way up to 3, right? 3 is the maximum number, so you can say 1, 2, 3. Since that, if you can make it a bit bigger, extend a bit, 1, 2, and 3. That's good. Okay, so that's what we have. Now we can try to sketch. So for the first one, the function we have is a quadratic function moving from -1 to 0. Okay, so you can come up with a table of values first. So f of x and then value of x. Alright, so we have -1, 0, 1, 2, 3. This is just a rough one, very fast one. Okay, so for -1, the function that applies is this quadratic function. So instead of calling it a quadratic function, I'll call it a quadratic equation because the function is only 1. Okay, so -1 is included because of less than or equal to x part. So if you put -1 in that equation, -1 squared is 1 minus 1 to give us a 0. So that tells us that we are starting at that point, -1, 0. And then of course, you can, out of curiosity, you can try the number between -1 and 0, which is of course -half. -half squared is +1/4 minus a 1. So I believe that is going to give us -3/4. -3/4. So if we say our n is somewhere here, then we expect it to be somewhere 3/4 below. So you can say almost there. And then of course, if you put a 0 there, just to estimate where it's going to end, of course 0 is not supposed to be included. So if you put a 0 there, it will give you -1. So at -1, it is not necessarily continuous. So just say the function is moving like this. Okay, it's moving like that. So at this point, it is not continuous. So that is at t. Take note, this is at t, -1. Okay, and then we can continue. Then the other part is also starting from 0, but 0 is also not included. So we can just put it there, we can just estimate for the sake of. So if you try to put a 0 in the 2x, it will give us a 0. So it's like that one is at 0, 0, but it's also not continuous. Okay, that's very important to understand. So I'll use brew for that. So something like that. And then that one is a straight line, so it's 2x. So we can also try to put a 1 If we put a 1 there, it's going to give us a 2, right? So 1 will give us a 2. So let's say this is 1, and then that is 2. So we're getting a 2. Now, it is not continuous because 1 is also not included, unless there's a dash down there indicating equal to. So, and that is a straight line. So it's going to be like that. And then from there, the next part is x is equal to 1. This is as x is equal to 1. So that is a function. In fact, that is y is equal to 1. So we just have like a dot. So it's existing at this point. So that one is existent. So shade inside. And then we are starting again from 1, but 1 is not part. So this is a linear equation. So if you plug in a 1, y is negative 2, to be negative 2 plus 4, giving us a 2, right? So 2. So 1 comma 2. So it's also starting from that point, but also not continuous. And then it's also a straight line. So you can try the next point, which is 2. If we put a 2 there, to be negative 4 plus 4, giving us a 0. So it's moving like this. It's a straight line. Now, is it existent at 2? If we check at 2 again, we are seeing that at 2, 2 is not part of. So we'll just draw a circle there to just indicate that it's not continuous at that point. Okay, so not continuous. And then from there, again, the last function as well is not continuous. 2 is not part of it. And then it's moving, it's f is equal to 0. So the y is equal to 0 is the x-axis itself. So it's moving all the way up to 3. But 3 as well is not part. So even at 3 as well, we need to be very careful and show that it's not continuous. Like that. Knowing that is 3. And then for the sake of just showing, I can use a different color along the x-axis to show that the function continued like that. Okay. So we finally now sketch the entire function on the graph. And then I can remove this so that we have enough space to answer. And then remove all those things that we are helping us. Okay, there we are. So can also make this one a bit clearer. So here what we had is we had negative 1, and then we had negative 1 there as well. And then of course here it's a quadratic, so it moved a bit like, started from there and then moved like that. At this point it's not continuous, very important. Okay, because at 0 it is not part. Okay, so I think we have it on our graph now. So we can now try to answer bit by bit. So the first one says, is f continuous at negative 1? So what does it mean for a function to be continuous? So for a function to be continuous, it means, before I talk about the formal definitions under calculus, for a function to be continuous, it means the function exists at that point, and then the limit also exists. So when the function at a given point, let's say at the point C, f of C, when it is equal to the limit of a function as x approaches C, when the limit at that point and the value of a function are equal, the function is said to be continuous. Okay, so what does that mean? So in this case, if you try to assess that point, you can see that I've shaded inside, which indicates that the function is what? The function is existing at that point. So we can say f of negative 1 is equal to what? If you substitute in that equation, even from the graph you can tell that it's what? It's equal to a 0. Now what is the limit as x approaches -1 for that function, for a function, it's also equal to what? -1. Because if you come from the left, of course from the left you don't have anything, but since you're coming from the left, it will just be at that point itself. It's already existing. Then coming from the right, using this curve, we are reaching -1. So are we reaching -1? Sorry, we are reaching 0. I mean to say we are reaching 0 because we are putting the y value. So since these are equal, we can confidently answer the first one to say the function is continuous. Yes, because f of -1 is equal to the limit as x approaches -1. They are all equal to 0. So we've answered the first one. We can go to the next one. Is the function continuous at x is equal to 1? So why is x is equal to 1? There we are. So what is the function at that point? F of 1 is what? So it's existing at that point. It's also equal to 1. Now what is the limit? So the limit as x approaches 1, so we start from the negative side. From the negative side, we observe where the function is. So this is the negative part of 1. So as we approach 1, the function is reaching that point. It's going towards what? It's going towards 2. So what is the limit from the negative side? From the positive side, which is this one, before 1, after 1, so it's also coming towards the same point as it reaches 1. So it's also equal to that. So which is also equal to the limit as x approaches 1 from the positive side. So since that is the case, we can clearly say that the entire limit itself, the limit becomes x as x approaches 1 is thus equal to 2. So now if you check the 2, are they the same? No, they are not. So the function is clearly not continuous because the limit is not equal to the function at that given point. So this one is a no. Now at what values of x is the function continuous? So we can clearly indicate the points where it is discontinuous. So we'll just come up with a set to describe that anyway. So we can clearly see that point. At that point, if the function is continuous, so since -1, since it is part, we'll say from -1, I'll use that bracket under set theory, all the way up to, that is 0. Now 0 is not, at 0 it is not continuous, as we can see, because we've not shaded inside, so it's not. So we'll combine that with, again, the function is continuous again from between 0 all the way up to 1, but at 1 itself it is not continuous, as we saw. And then union, again between these 2 points, again that is from 1 to 2, function is continuous, but they are both not part. And then again it is continuous between 2 and 3, again 2 and 3 are not part, so that's why I'm using the curved bracket. So we can see that from the domain, only -1 itself is part, and also the points where we are seeing the line continuously. That is the point. Those are the points where the function is said to be continuous. Okay, so I believe you understand what that means now. So take note of that. We are now on the second from the last question, which is D. What values should be assigned to f of 2 to make the extended function continuous at x is equal to 2? So why is x is equal to 2? So x is equal to 2 is this part. Okay, so x is equal to 2. So what can we say about x is equal to 2? The function f of 2 itself is equal to what? F of 2 does not exist. As you can see from the graph, f of 2 does not exist. Okay, does not exist. Then what's the limit? So the limit as x approaches 2, from the left and the right hand side, they are all coming towards this very point, which is 0, right? So if we want the if we want the limit to be if we want the function to be continuous at that point, then the function of the f of 2 should also become equivalent to what? To the limit. So it should also become equal to the limit of the function as x approaches 2. Of course, I need to indicate f of x, which is equal to what? 0. So a function of the value of f2 at x is equal to 2 should also become what? Should become 0, so that it is equal to the limit. Then the function is going to become continuous at that point as well, because as it stands, the limit is equal to 0, but the function itself does not exist because it is not defined. So the function will become continuous thereafter. And then finally the last one says, to what new value should f1 be changed to remove the discontinuity? To what value should f of 1 be changed to remove the discontinuity? What does that mean? What does that mean? So if you look at f1, you can clearly see that the function itself at f1 is 1. Okay? The limit we saw clearly, in fact this is what I indicated here. The limit as x approaches 1 from both the positive and negative side is equal to a 2, as we can see. They are all approaching 2 from the left and the right. Okay? As x approaches 1, it's equal to 2. Now, to what new value should f of 1 be changed to remove the discontinuity? So we are changing the value of a function. So we can only change the value of a function. For it to be continuous, they're supposed to be equal to the limit. So just like we saw previously from the previous question, we'll do the same here. So a function value would have to go to that point, then the function become continuous at that point, or the discontinuity to be removed. So f of 1 is supposed to be equal to 2 as well, if we are to remove the discontinuity at that point. Okay, so this is where we end with question 1.
Okay, so option 2 is saying define f of 3 in a way that extends f of x is equal to x squared minus 9 over x minus 3 to be continuous at x is equal to 3. Now, to make this function to be defined so that it should be continuous at that point, what we have to do here is we can make even a piecewise function. Okay, so we can say f of x will be equal to, now I don't have space this side, let me use this side. I'll say f of x will be equal to, I know that if I plug in x in this function, it's going to be undefined, it's going to be 0 over 0. To make this function to be defined, I need to get the denominator, set it not equal to 0. So for x, so x should not be equal to negative 3. That is the first condition. So x squared minus 9 divided by x minus 3, the condition should be x should not be equal to negative 3. Now, what of the next one? Now, I can clearly see I can solve this in a such a way that since they are saying that it should be continuous at x is equal to 3, then I need to take limit. So it's going to be limit as x approaches 3 of the function x squared minus 9 divided by x minus 3. Now I know that if I plug in direct, it's going to be 0 over 0, and we're trying to avoid that situation. And I can clearly see that the top part here, this is the difference of two squares. So I can say lim as x approaches 3, this can be written as x minus 3 and x plus 3. It's a difference of two squares. If I have a minus b, okay, this is squared. This is the same as a minus b and a plus b. It's a difference of two squares. This is not the same as this. It's not. It's different. Now down here I have x minus 3. Now these two can be cancelled, so I have limit as x is equal to 3, x plus 3. So if I plug in direct now, once you want to plug in, you remove limit, so it's going to be 3 plus 3, which is going to be 6. What it means there is that if the answer is 6, okay, the condition should be x has to be equal to 3. So if x is 3, the answer will be 6. At that point, this is going to be continuous and it's going to be defined. So that is it for part A. Now for part B, I can clearly say that if I plug in 2 direct, I'm going to have 0 over 0. Therefore, I need to get the denominator to set it equal to 0. So the first part is going to be x squared minus 3x minus 10 divided by x minus 2. Now what is the condition? I need to get the denominator, set it not equal to 0. So for x should not be equal to 2. So it can be defined if x is not equal to 2, that is true. What else? I need to take limit as x approaches the number which have been given. Okay, so I'll say limit as x is approaching 1 of the function, or is 2, not 1. Limit as x is approaching 2 of the function x squared plus 3x minus 10, everything divided by x minus 2. If I plug in 2 direct, I'm going to get 0 over 0. To avoid that situation, I can clearly see that the numerator is a quadratic equation. So I can say I have got the product of -10, the sum of 3, which is positive 3. What will be the factors? I believe the factors will be positive 5 and negative 2. So that when I do this time this, I'll get -10, then negative 5 plus negative 3, I'll get positive 3. So those are going to be my factors. Now to factorize that one, it will be x squared plus 5x minus 2x plus 10. So x, then I'll have x plus 5 minus, here I'll factor out 2x plus 5. So meaning that on top there I'm going to replace with this. Okay, so I'll have limit as x approaches 2, x plus 5 and x minus 2. Now down here I have x minus 2. So I can clearly see that x minus 2 and x minus 2 can be cancelled. So if I cancel this, I'll have limit as x approaches 2 of x plus 5. Now let's plug in the values. So 2 plus 5 will be able to get a 7. Meaning that if the answer is 7, the condition is that x should be equal to 2. Meaning I'm done. Now I've defined this, and it's going to be continuous at that point. Okay, so that is it for part B and A. Now let's go to part C. So part C, we have so I have f of x will be equal to the first thing which I have is x squared minus 1, everything divided by x squared minus 1. Okay, what will be the condition? I need to get the denominator, equate it not equal to 0, because on the denominator we cannot have 0. So I'll have x squared should not be equal to 1. If I square root both sides, here I have plus or minus, so x will be not equal to plus or minus 1. Okay, so that will be the condition. The condition should be x should not be equal to plus or minus 1. Okay, then let me put the condition in different color. So the condition is that x should not be equal to plus or minus 1. Then the next one we don't know, but we have to take the limit. So it's going to be lim as x approaching that number which we have been given of the function x. Okay, it's x to a power 3. So what we are doing here is wrong because it's x to a power 3. Okay, it's x to a power 3, but the denominator, that is just okay. Now we are just concerned of the numerator. X to a power 3, because here I need to put x to a power 3, but what I have there is going to be the same. Then I have this. Okay. Now what we have to know is that if you have a to the power 3 minus b to the power 3, you can use this simple formula to say a minus b, then a squared plus b plus ab square, or plus b squared. Then this is the difference of two squares is going to be replaced by x minus 1 and x plus 1. Okay. Now if you have this is the difference with this. It's not the same. Okay. Now what we need to know is if you're not comfortable with this formula, you can just use polynomial. You can find the factor, and then you're going to use polynomial to factor out, and then you're going to have this and that. Okay, using polynomial. That is just okay. Now here I'm going to use this formula. Now in a case where I have a to the power 3 plus b to the power 3, I can use a plus b. Then here a squared minus ab, then plus b squared. So the difference here is here I'll have minus if there is plus, then here I'll have plus everything, and then here I'll have minus. Okay. What it means there is that limit as x is approaching that number. On top there we have not come up with the answer, but down here we can clearly see that we're going to replace this with that. Now let's see. I have got x to the power 3 and 1 to the power 3. 1 to the power 3 is still 1. So I have x minus 1. Then here I'll have my a is x in that case, now squared, plus my ab, so 1 times x to be just x, then plus that other one b squared, which is 1 squared is just 1. So on top here I'll replace that with x minus 1, then x squared plus x plus 1, like that. Now what I'm going to do is I'll say lim as x approaching 1. I can clearly say that these two guys can cancel. I'll have x squared plus x plus 1 divided by x plus 1. Now if I plug in direct, it's going to be defined. So this will be equal to, I'll have 1 squared plus 1 plus 1, then 1 plus 1. So I have 1 plus 1 plus 1, 3 over 2. Meaning that the answer is 3 over 2 when x is equal to 1. So I'm done. Now at that point it's going to be defined, and then it's going to be continuous. Now let's go to the last one, which is D. So D, I have let me just get rid of this. So it's going to be, I can write this. So I'll have x squared minus 16 over x squared minus 3x plus 4. What will be the condition in that case? So the condition is that x, anyway, we need first to get the denominator. We have x squared minus 3x minus 4 should not be equal to 0. Now I have the product of neg 4, the sum of neg 3. The factors, I believe is negative 4 and positive 1. So that if I do this plus that, negative 3 times negative 4. Meaning I have x squared minus 4x plus x minus 4 should not be equal to 0. Then I can factor out x, so it will be x minus 4. Okay, here I factor out 1, x minus 4 should not be equal to 0. So x plus 1 and x minus 4 should not be equal to 0. If I shift this to the other side, I'll have this x minus 4 should not be equal to 0. Therefore, if I shift 1 to the right hand side, x will not be equal to 1. This other one, x will not be equal to 4. Now the condition is that since I don't have enough space here, allow me to push this one a bit, then I put this one here. So for x squared minus 16 divided by x squared minus 3x minus 4, the condition is that this x should not be equal to neg 1, okay, and x should not be equal to 4. Now let's take the limit. We have already seen that the down part there, we can replace it with this. We have already simplified. We're going to replace it with that one. So let me just put it here. We'll replace it with this. So let's take the limit. So limit as x is approaching the number, which is 4, of x squared minus 16, then x squared minus 3x minus 4. Now we have already simplified the down part to this. Okay, so I have lim as x is approaching 4. So x squared is a difference of two squares, where I have x squared minus 4 squared. So this is x minus 4 and x plus 4. So I'll replace that one with x minus 4 and x plus 4. Down part I'll replace with x plus 1 and x minus 4. Now I'm doing this because if I plug in 4 direct, I'll get 0 over 0. This and this can be cancelled. So now I'm remaining with lim as x is approaching form of x plus 4 divided by x plus 1. Plugging in the values direct, that's when you remove limit. 4 plus 4 divided by 4 plus 1. We'll have 8 divided by 5. Meaning that this is the answer now. So if the answer is 8 divided by 5, the condition is that x should be equal to 4. Then I'm done. So that is it for question 2. So we have question 3, which is saying for what value of a is f of x, which is a piecewise function, continuous at every x. Now we know that for a function to be continuous, this condition has to be fulfilled. Limit as x approaches any number from the left side of f of x should be equal to limit as x approaches that number from the right side of f of x. If this condition is fulfilled, then the function is continuous at that point. Now here we can clearly see that we have 3, and again we have 3. This is saying x is less than 3, but this is saying x is greater than or equal to 3. So I need to get the same one. So I'll say limit as x approaching 3 from the left side of f of x. Now the function there from the left side, I'm going to get the first one because this is telling me that it's less than. So I'll get x squared minus 1. This has to be equal to the limit as x is approaching 3 from the right side. Now from the right side, I'll get 2ax. Now let's plug in the values. So this is going to be 3 squared minus 1 to be equal to 2a, x is 3. So I'll have 9 minus 1 to be equal to 6a. So this will be 8 is equal to 6a. Dividing both sides by 6, even here by 6, these can be cancelled. A will be equal to 8 over 6. But it can be further simplified because 2 can go into 8 and 6. So 2 into 8 is 4. 2 into 6 is 3. Now my A value is 4 over 3. As simple as that. Now, what we need to understand here is that if I plug in a to be 4 over 3, the answer is going to be the same if I take limit as x approaches 3 from the left side and limit as x approaches 3 from the right side. We can prove this. Okay? Now, limit as x is approaching 3 from the left side. Now, from the left side, I can clearly see that it's going to be I have x squared minus 1. So I'll have 3 squared minus 1, which is 9 minus 1. I'll get 8. I need to get the same answer to the right limit as x approaches 3 from the right side. So I'll have lim as x is approaching 3 from the right side. From the right side, so I'll get the one which is saying x is greater than 3. So I'll get, it can be greater than or equal to, but we can clearly see that this is saying x is greater than or equal to 3. So I'll get the same one. Now we plug in the values. A is 4 over 3, then x is 3. Now I can see that these two guys can cancel out, because if I multiply there, I'm going to have 2 times 4 times 3 divided by 3. These can be cancelled. So I have 2 times 4, 8. I can see that I have 8, I have 8. So the A value is indeed 4 over 3. Let's go to part B. So they're saying for what value of B is f is g of x continuous. So like we said, you're going to say for a function to be continuous, you have to write this condition. That is the first thing. For a function to be continuous, this has to be true. X as it is approaching, you can use A or C. So say g of x has to be equal to limit as x is approaching c from the right side of g of x. Now I have limit as x is approaching that number. I have this number. Always I'm going to have the same number there. I just get that number. Now from the left side, negative 2 from the left side. The one which is saying less than is just x. Has to be equal to lim as x is approaching neg 2 from the right side. The one which is saying greater than is b x squared. Let's plug in the values. So here is going to be negative 2 will be equal to b, here negative 2 squared. So it will be negative 2 is equal to 2 times negative 2 times negative 2, it will be 4b. So I have negative 2 is equal to 4b. We divide both sides by 4, both sides by 4. So b will be equal to, these two guys are going to cancel. So I'll have neg 1 over 2. Because 2 into 2, 1, 2 into 4, 2. That is the value of b. Believe me, if we plug in the value here for b, the answer is going to be the same. Okay, we can prove that if we want, but we are going to find the same. So you prove using the same method which I used to prove for part A. So that is it for question 3. So question 4 is saying using the definition of the derivative, which is from the first principle, calculate the derivative of the following function, then find the values of the derivative as specified. So this question, we can see that we have got a from a all the way to f. So I'm not going to solve all of them, but I'll just choose few. Okay, but I'll start with the first one. Okay, so the first one is saying f of x is equal to 4 minus c x squared. Now when you are differentiating using the first principle, we always use the formula. Now let me just shift this one to be on top a bit because I will need enough space. So um, it is the f of x prime limit, that is the formula, as h is approaching 0 of f of x plus h minus f of x, everything divided by h. What does it mean? In the function of x, where there is, in the function of f, where there is x, we are going to put x plus h, and then minus the original function. What I mean here is, like in this case, I'll say limit as h is approaching 0, then I have 4, okay, minus, where there is x, I'm going to say is x plus h. Now since that is squared, I have to square it, minus the original function, which is, now this function, because this minus or this negative is affecting everything, I need to put this in brackets. So I'll have this, everything has to be divided by h. Now you need to be very much careful here. Since I've got two things here, I need to put this in brackets because this negative is affecting the whole function. Okay, so then I'll have limit as h is approaching 0. This is the same as 4. If I can factor out, if I can just simplify what I have inside there, it's the same as I have this. Now again, if I do this times that, if you want you can do direct, but some they are having problem to do that, so I'll just do it like this way. So I have x plus h. Now I have x times x is x squared, x times h is xh, plus x times x is xh, plus h times h is h squared. These two can be added, so I have x squared plus 2xh plus h squared, meaning that everything here is going to be replaced by that one, by this. But remember, outside there we have a negative, and we have to say negative is going to affect everything there. I'm just copying. Then minus, here if I distribute negative, is going to be negative 4 again plus x squared. Okay, yeah, then everything divided by 4 or divided by h. Initially, if you are just differentiating this direct, not using the first principle, this one, you know that dy over dx, in this case it will be, the derivative of 4 is 0, then the derivative of negative x squared is going to be negative 2x. So what we are doing here, we need to come up with the answer, which is going to be negative 2x. Okay, let's go ahead and see what we're going to have. So I have lim as h is approaching 0, I have 4. Now I can distribute the negative, minus x squared plus 2xh plus h squared. What else do we have? Then I also have minus 4, then plus x squared, everything divided by h. At this point I can clearly see that I have got x, negative x squared, and just x squared. Those two can be cancelled because there is minus there. These are going to give us 0. What else can we see? I can see that 4 minus 4 is going to give me 0. Therefore, I'm now remaining with limit as h is approaching 0. I'm remaining with 2x h plus h squared divided by h. If I plug in direct here, I'll get undefined. I can factor out h on top. So I'll have lim as h is approaching 0. If I factor out h on top, I'll have 2x plus h divided by h. Now at this point, I can clearly see that h and h can go. I will remain with limit as x is approaching 0. 2x plus h. Now here we had a minus. There's an error here. There's a mistake. Here we have minus, which is here, this negative here. This negative times this, we have said is negative. Negative times that one, this is supposed to be negative. Okay? This is supposed to be negative. At the same time, because this is positive, also here we are supposed to put negative. Because negative times positive, I need to get negative. Then again, negative times this, I need to get a negative. Now, meaning that here we have a negative. Here we also have a negative. That's why it's good for you to differentiate using a normal way. Okay? And then you'll be able to see, to say, here there's a mistake, I need to do this. As you can see here, I made a mistake because I didn't distribute negative to negative to 2xh and h squared. Now here there is negative, here there is negative, so I can just start from this point here. Here everything is just okay. So limit as h is approaching 0, I factor out what? I'm factoring out h. I will remain with negative 2x minus h over h. H and h can go. Lim as h approaching 0, I'll have negative 2x minus h. Now if I plug in direct, it's going to be defined. Where there is h, we put 0. So our answer will be negative 2x. Now the question is, we differentiate and then we start now finding the values. Where there is x at the first one, we should put, the question is, we need to find f of prime negative 3. So where there is x, I need just to put negative 3. So it will be 6. Now if I put 0 where there is x, then I'm now doing this. F of prime of 0, I'll have negative 2 times 0, I'll get 0. What if I put 1? It will be f of prime of 1, I'll get negative 2 times 1, which is going to give me negative 2. So that is it for part A. Now I've given you a hint. I believe we can do part B, but we can do part B together. Let's see. Now, using a normal way on how to differentiate part B, the final answer has to be, I can use chain rule. Okay, so to find dy over dx, I drop the power, is going to be 2 times this one is constant times the derivative of what is inside. The derivative of what is inside is just 1. It's 1 minus 0, so it's going to be just 1. Now the derivative of 1 there is just 1. So this is going to be the, so we need to arrive there. That will be the answer. Okay? So now, the issue here, using the first principle, limit as h is approaching 0, I'm going to have, we first need to write the formula, which is this, everything divided by h. Okay? Now, what we're going to do is limit as h is approaching 0. Now, where there's x, we need to put x plus h. So I'll say x plus h, then I have got minus 1. So this is squared minus the original function. Now, the original function, everything has to be in the square root. Okay? Because this negative will affect everything inside. So I divide this by h. Okay? Now, if we distribute this, which we have here inside, I can do it just separate. So it's going to be, let me do it from here. I have x minus h or plus h, then minus 1. Again I have x plus h minus 1. I'll start x times x, I'll have x squared. X times h, I'll have xh. X times negative 1, I'll have negative x. I'm done with x. Let's go to h. H times x, I'll have plus xh. H times h, I'll have h squared. H times negative 1, I'll have negative h. I'm done with h. Let's go to negative 1. Negative 1 times negative x, I'll have negative x. Negative x times, or negative 1 times h, I'll have negative h. Negative 1 times negative 1, I'll have positive 1. Now the like terms together, this is just alone, but xh, I have xh and xh here, so I have x squared. Xh plus xh, that is going to give us 2xh. Also we have x and x, which is going to give us negative 2x. We have also h and h, which can give us negative 2h, then plus 1. Okay, so this is alone and this is alone. This has added up with that one. This have added it with that one to give us negative 2x. Then h and h negative 2h. So on top there, I'm going to replace that one with what I've just come up with here. So I'll have limit h approaching 0. Everything will be replaced by this. Okay. Then minus 2h. What else? We have plus 1. Then here now I have minus. Remember, inside here I need first to factor out this. I need to simplify this one, which is going to be x times x to be x squared. Then x times times negative 1 is going to be negative x. Then negative 1 times x, negative 1 times negative 1, positive 1. So I'll have this 2x plus 1. So inside here now is x squared plus 2x plus 1. Okay, but again I have also plus, okay, plus 1, but again I also have another one here, plus 1 plus 1, which is this one outside here. Okay, now everything is divided by h. Let's now remove the brackets there. So I have limit h approaching 0. This x is squared. Okay, the x is squared and the h was also squared. Where is the h? I believe we have left h, which was squared. Just a minute. Here, this was squared, and then h was also squared. No, we need to have h which was not squared. Let me just, okay, let's just put this one here because I've just erased what I had here. Now that one we are going to replace it with x. Okay, I've seen it. So we're going to replace with this. Let's just do this. Because I'm talking about this part here. I have forgotten to put h squared. So it's x squared, which we have. Then xh plus xh is 2xh. X plus x, we found negative 2xh. So here I need to put h before 1. Should be h squared because we have h squared here. Then minus, or it's now plus 1. Okay, now it's making sense. So we go back. Lim h is approaching 0. x squared plus 2xh minus 2x minus 2h plus h squared plus 1 minus this one. I've distributed it already, which is x squared plus 2x plus 1 again plus 1. So 1 plus 1 I can just say is 2, which is the same just. Okay, now I can get rid of this. I no longer need that. I divide everything by h. I want to distribute the negative there, so I'm going to have this one has to be negative, this part here, because it was negative x minus x, so it's negative. So I'll have limit h is approaching 0, x squared plus 2x h minus 2x minus 2h plus h squared plus 1 . Okay, we have plus 1, then minus x squared plus 2x minus 2, everything divided by everything is divided by h. Let's see what we can cancel. X squared can go. What else? 2x can go. What else can we see? Okay, so I'm remaining with okay, so here we have 1, which can give us negative 1, meaning we are now remaining with lim as x is approaching 0. I have 2x h, then I have minus 2h plus h squared. What else do we have? Then I also have I'm remaining with this, and that is going to be negative 1, everything divided by h. Now let's try to plug in the values. Initially I feel like we have made a mistake because this was supposed to be 2 at some point, and this mistake has just happened when we were factoring out. Okay, but okay, without wasting our time, let's see if that was supposed to be 2, because we're not supposed to have this, I believe so. Yeah, because yeah, exactly. So what we're supposed to have there is because here I'm going to factor out h. If I factor out h, I'm remaining with 2. Okay, let's do this. Let me restart solving this one so that we see the mistake which we made. We are saying limit as h approaches 0. Now the formula we know it already. I'll just plug in direct. We are saying we are supposed to say where there's x we put x plus h. Okay, so I'll say x plus h minus 1, but since it is squared I have to square it. Okay, okay, I forgot 1 here. I didn't put 1. Then minus the original function, I didn't put 1. So the original function I need to put the brackets, x minus 2, then squared, then we'll have plus 1, like that. Yes, everything divided by h. Now let's simplify this. We said that simplifying that one, we have x plus h minus 1 and x plus h minus 1. Simplifying that, I'll start with x. X times x is x squared. X times h is xh. X times negative 1 is negative x. I'm done with x. H times x is plus xh. H times h is plus h squared. Then h times negative 1 is negative h. I'm done with h. Negative 1 times x is negative x. Negative 1 times h is negative h. Negative 1 times negative 1 is plus 1. Perfect. Now it's making sense. So what are we going to have? We're going to have, if we simplify this, x squared, x, this and this can be added. We'll have 2xh. X and this and that can be added. We'll have negative 2x. Then h and h can be added. We'll have negative 2h, because this h and that one. Then plus h squared plus 1. Now this one, the way we simplified it, that was just okay. We didn't make any mistake. Okay, let me just shift this to be down here. This one we simplified. We said it gave us x. In case, let's redo it. We are saying x times, okay, this one gave us x squared. Let me put it in red. It gave us x squared minus 2x plus, this is 1. Okay, it gave us x squared minus 2x plus 1. So this is going to be limit h is approaching 0. Everything here, what we're talking about here, we're talking about the one which is just squared, meaning we have x squared plus 2xh minus, I'm just copying this, minus 2x minus 2h, then plus h squared, then plus 1, again plus 1, this one here. Here, minus, everything has to be in the brackets, x squared minus 2x plus 1, again plus 1, like that. So this has to be divided by, I need to divide this by h. Now, let's distribute the negative. I no longer need this. But before we do that, h, let me say limit as h approaching 0, x squared plus 2xh minus 2x minus 2h plus h squared. 1 plus 1 is 2 minus, this is going to be, inside here now we have 2. If I can just add those two, 1 plus 1, I'll get a 2. Let me just put here a 2. So plus 2. It's going to be negative x squared plus 2x. Okay, then minus 2. I divide this by h. Now let's see, x squared and x squared can go, 2x and 2x can go, 2 and 2 can go. It's going to give us 0, those two guys. What else can we see? What else can we see? What else can we see? Okay, now we can see that, okay, now we can see that on top there we are going to have limit. Remember, our goal is to come up with this answer. That's why it's good for us to differentiate using the normal way, so that when you are using first principle, you know the answer already. So limit as x is approaching 0, I'll have 2x, okay, minus 2h, then I have minus, or it's plus now, plus h squared. everything divided by h. Believe me, if I can plug in h as 0 direct, it's going to give me undefined. So to make this defined, what are we going to do? We factor out h on top. Limit h approaching 0, I'll factor out h alone. Okay, so I'll say h, here I'll have 2x. Yeah, I'll have 2x. Then here I'll have 2. Here I'll have h over h. H and h can go. Now I have limit h approaching 0, 2x minus 2 plus 1. Oh, plus h, sorry. Let's plug in the values. We'll have 2x minus 2 plus 0. So we'll have 2x minus 2. But this one, I can factor out this one. I know that even here, if I do 2 times that one, is going to be 2x plus that one, so which is going to be 2 open brackets x minus 1. Now that is making sense. That is what we found there. Now the question is, we need to plug in now the values. We put negative when g of prime is negative 1, meaning 2 negative 1 minus 1. So I'll have 2 times 2, which is negative 4. If I put 0, let's see, g prime of 0 will be 2. I'll have 2 negative what? I'll have negative oh, it's 0, so we are plugging in 0 minus 1, so it will be 2 times negative 1, which is just negative 2. Now you can also go ahead and plug in, you put 2 minus 1 is 1. 1 times 2 is going to be 2. That is part B. Now for part let's see, for this one, part C, so we are now on question 5. So question 5 is saying, in the following, find the indicated derivative. So the first part is we need to find the derivative of okay, so we are now on question 6, which is saying differentiate the following function and find the slope of the tangent line at a given value of the independent variables. Now we are on question 7, which is saying differentiate the following function and then find an equation of the tangent line at the indicated point on the graph. So we are on question 8, which is saying, okay, so question 9 is saying, for each of the following function given below, answer the following questions. Find, so we have y is equal to x to the power negative x to the power 2. Find the derivative of y of a given function for one function. Okay, so we have question 10, 11, and 12, which is basically the same concept. So question 10 is, does the equation y is equal to 2 the root of x have any horizontal tangent?